Hey, welcome to today's edition of Science Madness. We are joined today by Josie and Judith Meister. And girls, you want to give a quick introduction of what you're going to do?
Today, we're going to deal with Alka-Seltzer. What happens to Alka-Seltzer when it's put in different temperatures of water, Josie?
I don't know.
Let's find out. For this experiment, you will need Alka-Seltzer, water, just regular tap water, and then if you have a microwave available to heat up water with your parents' permission, that would be great, along with a container and about a 1/4 cup measuring. So then that way for the water. Okay. Just a warning, do not eat the Alka-Seltzer tablets. It's not good for you. Don't feed them to your siblings or your pets. It's not good. Okay, so let's begin. So first, you're going to need to take a 1/4 cup of your water, just like this, and put it in your container. Okay. Now you're going to take one of your Alka-Seltzer packets, and you're going to open it up, and you're going to take out both of the tablets. Okay, since this is going to create an explosion of some sort, we're going to go outside so we don't make a mess in my mom's kitchen. I suggest you do the same. So what you're going to want to do is you're going to want it on the ground, and this is, you're going to take both of your tablets, and you're going to set them in there very quickly and safely put on the lid. Okay, once you put on the lid, you can shake it up a little bit, turn it upside down, and just wait, because the gases that, as you can hear the noise, it's popping. Just like that. As you can see, the Alka-Seltzer tablets did not fully dissolve, which is okay. But it's still creating an explosion of some sort. So that's kind of fun. And look at all the bubbles and the gases releasing from the tablets. This explosion, we are just using water, room temperature water. Whereas we're going to go in and we're going to see if we can create water that is warmer and see if we can get a bigger explosion or a smaller explosion. We're going to kind of see what the temperature of the water does to the Alka-Seltzer tablet. All right, so let's go and find out. So you're going to want to take a container that's microwavable. Or you can, if you want, with a parent's permission and help, you can use a stove. Probably let your parents do that part of it though. And then if you want, you can grab a glass that's microwavable or a container that's microwavable and put it in there for about 10 or 15 seconds. So I got about a 1/4 cup of water here that I'm going to go microwave. The water is now hot, so I'm going to quickly rinse out my container and put the water in there.
It's a really good idea to use that Pyrex because it's designed to resist heat even beyond boiling. And we use Pyrex like that in the lab.
Yep. Now I'm going to take my 2 tablets with me outside again. Now I'll be thinking, is this going to, remember from the past explosion, it took about a couple seconds, about maybe 5 to 8 seconds for the reaction to occur. Let's see how fast this one's going to recur since we changed the temperature of the water. On the ground again. This one you're going to be a little bit more quicker, or a little bit more faster, I guess. I don't know how to say that. Because it is probably going to be a little bit faster. Door.
Okay, so that didn't work so well because I didn't have the lid on fully or quite tight, but it would create a larger explosion. As you can see, it did happen a lot faster than the other one, because the temperature of the water was warmer, so the faster it reacted with the Alka-Seltzer. As you can see, the Alka-Seltzer is a little than the base, and there's a lot more foam along with it. So one of my errors that would happen with this lab, or things that did not go correctly, was I didn't get the lid off fast enough. But we did see that there was a difference. So changing the water temperature. And then maybe if we change the water temperature, if we make it colder, we'll make it slower or we'll make it faster.
So for this next part of it, you're gonna want to go to your faucet and get turn it on to make it as cold as possible. And it even helps if you stick it in the freezer for a little bit. So trying to figure out like what different temperatures you can do if you go like really cold, so you can stick it in the freezer for a couple minutes, or if you go really fast and then you go really warm, or you just have a standard room temperature. So changing the temperatures of the water can change how fast the reaction occurs. Any questions?
Yeah, I'm thinking if we can get you 3 or 4 containers, especially round ones or cylindrical ones, I think the lids will stay on better. And then we could do this simultaneously, side by side, and that would be very cool. And that's something I think I might be able to go shopping and find some of those Rubbermaid ones that snap on tighter. Because if you can have a tighter snap on, you'll have more pressure build up before the breaking point, and then you'll get a more convincing explosion. And plus, if we can do all 4 side by side and put the lids on all at the same time or close to the same time, that'd be very cool.
You could do it with balloons as well, and then you can really visualize the difference in how quickly the gas is being released.
Yeah, but they don't blow up, do they, Liz?
They
Let's
do.
do it. Yeah.
This is quicker gas. This isn't like yeast. This is like
Yes, these must be the male balloons.
This is like a quick gas release, you know. I agree. It's boring with yeast, but it's way different with Alka-Seltzer.
That is a good idea.
So the question in the chat, Josie and Judith, is: do you have any idea what the heat or the temperature of the water was after you heated it, or at room temperature?
It was very hot to the touch. It was boiling in the microwave.
So we could see about getting you thermometers that you could read those out. And if that would be another thing that would be cool, because one option is to get 4 water baths of the temperature that you want. And then you put that 1/4 cup of water in the whatever container you're using from that water bath, and you put it back in. And then it's much slower to change the temperature because you have a big amount of water. Mm-hmm. And so we could measure that. We could put the caps on. We could do the balloons like Liz was talking about. I could send you some of those veterinary gloves, and that's pretty good theater. Mm-hmm. Because then you get a 3-foot long glove. And for the Meister crew, can you tell me what's in Alka-Seltzer? I don't know what's in there that generates the bubbles.
Aspartame.
Aspartame? Okay.
Yep. And sodium bicarbonate.
Mm-hmm.
And then what? Sodium bicarbonate alone, I don't think is going to make gas, does it, Liz?
No.
Bicarbonate's baking soda.
It's baking soda, exactly.
Don't need an
acid.
Ding, 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 ding.
Yep.
Okay, so those are 2 powders, I think, that that are not very active since they're powders. Mm-hmm. And then when you put it into the water, they start doing the acid base thing.
Mm-hmm. Liz and Tom, if you don't know,
let's find out.
Let's find out.